It is an Ericsson standard to use fire-retardant coaxial feeder cables for in-building installations. This is a coaxial cable drum. The type of feeder cable to be used for an installation depends on the power budget calculations. By using the length indicator on the cable, one can cut it to its correct lengths. The jumper cables are short, flexible and pre-connectorized. They are used for linking components in the distributed antenna system, making the feeder cabling neater and tidier. It is an Ericsson standard to use jumper cables with N connectors. Splitters are used for equal power splitting. The type and quantity of splitter depends on the number of branches for distribution. The performance of these components should be verified in both uplink and downlink directions before they are installed. Tappers are used for unequal power splitting. They enable an even distribution of signal power in the system. The tappers facilitate the tuning process, since they control the antenna effective isotropic radiating power during the optimization phase. The multicasting matrix is a very versatile device that combines multi-operator systems of the same band or combines multiple TRUs into a single cell. It offers relatively low loss and multiple outputs for signal distribution. Diplexers and triplexers are special filters that combine 2 or 3 systems of different frequency bands into a single output with a very low insertion loss and high isolation. Male and female connectors are available for all cable types and sizes. Recommended connectors must be used for optimum performance of the distributed antenna system in order to avoid any performance degradation. It is an Ericsson standard to use N male connectors. Adapters are used for interfacing 2 cable ends or any other network element with similar or different connectors. The power terminators or dummy loads are matching loads that terminate the RF signal power for various reasons in the distributed antenna system. Power terminators are used for radiating cable termination, unused distribution branch termination, unused ports at any network component, and for voltage standing wave ratio measurements. The combining box consists of multicasting matrix, diplexers, triplexers, and input filters. It is mounted either in a 19-inch rack or wall-mounted. It is always preferred to house the combining box closely and centrally to the RBSs in order to minimize the cable loss. All relevant building regulations and building house rules shall be adhered to during the installation process. RF feeder cables shall always be supported by cable trays in environments with exposed ceilings. The width of the tray shall cater for both the current number of feeders as well as any future requirements. Cable installations in car parks and telecom risers can be done on either existing or new cable trays. All cables should be laid as a single layer and secured in the tray using appropriate cable ties. Inside buildings, cables are to be installed above false ceilings. In cases where trays cannot be installed above false ceilings, cables should be secured directly onto the existing anchorings. Cable bending radius should always be observed not to exceed the limit. Overbent cables will always be under stress and cause damage to the cable and connector, degrading the RF performance. As a rule of thumb, cable bending radius should be higher than 10 times the cable outer diameter. These installations are perfectly acceptable. All cables shall be clearly marked and labeled. Cable markers and labels shall be clearly visible. It is recommended to have cable markings at regular intervals. Cable label tags shall be fitted at cable ends and to components in accordance with the trunking diagram. Proper marking and labeling will facilitate the processes of expanding the system, troubleshooting, and maintenance. It is an Ericsson standard to use N-male connectors. The cable ends are prepared using the proper tools, and the connectorization is done as per the instructions given for each connector. Trim cable jacket for 51 mm using a special tool or a knife. Add O-ring and grease. Insert the clamping nut and spring ring. Position the saw guide and cut the outer conductor. Remove the dielectric foam and the adhesive. Trim inner conductor and tapper inner conductor. Compress the foam and flare outer conductor. Remove the debris. Add grease and attach connector body. Tighten the clamping nut by using the right-sized spanners while keeping the connector body stationary. Trim the cable jacket for 38 mm in length in the corrugation valley. Position the saw guide at 25 mm away from the jacket and cut the cable flush with the front of the saw guide using a fine-toothed saw. Take care not to distort the outer conductor. Deburr the inner and outer conductor. Care should be taken not to flare the outer conductor. Compress the foam around the outer conductor and ensure that the outer conductor is in its original round and undistorted shape. Screw in the connector pin. Make sure that the clamping nut is fully extended. Push the connector on the cable and turn the clamping nut clockwise to engage the threads and tighten with the right size spanners while keeping the connector body stationary. After the cable has been connectorized at both ends, the voltage standing wave ratio measurement is carried out using the Sightmaster tool for each cable section with a termination at the other cable end. The instrument needs to be calibrated before tests begin, or if it's been turned off and on. The results are recorded and presented in the as-built documentation. If the result is not within specifications, the cable should be reconnectorized until it fully meets the specification. The distance to fault measurement is done at the same time as the VSWR measurement. The test result will dictate any faults along the entire cable length. Splitters and tappers should be mounted on the cable trays and secured by cable straps on mounting brackets. Care should be taken not to mount the components in the wrong direction. Different types of bracket installations suitable for various antennas and locations in the building are illustrated here. For exposed ceilings, one should mount the Omni antenna on a bracket. For false ceilings, one can mount it directly to the ceiling. Here is a panel antenna being installed. The antenna must be aligned in accordance with the instructions in the direction indicated in the RF design. Here is a bidirectional antenna being installed. Antennas are aligned as per the direction indicated in the RF design. Once the installation is completed, one performs an installation audit with the building owner to ensure that all installation criteria have been fulfilled. The installation audit is followed by the testing and commissioning of the radio equipment. The antenna performance test is to ensure that all the antennas are functioning properly in both the downlink and uplink directions. A coverage test is conducted on every floor by walking along a pre-agreed path and recording the signal strength using a TEMS light. This is to ensure that the designed and implemented coverage is the same. If any discrepancies are found, appropriate coverage tuning should be made. A spillage test is conducted to measure the in-building signal received outside the building. Signal spillage should be controlled and should not exceed the specifications stipulated by the operator. After the coverage tuning, an acceptance test using TEMS light is conducted together with a representative from the operator. An acceptance test report is submitted to the operator after the test. All of the installation and RF aspects of the completed in-building design are carefully documented in the as-built documentation. This will facilitate any future expansions and maintenance work.